one dot on like the bottom and then like 20 dots on the top. It should be like going through the middle and trying to balance out where all the dots are.
There. So we're trying to equalize dots above, dots below, right? So you might need to zoom in to get that equalization of dots above, dots below. But like Carter said, we want to be following the trend that we see from our data points. Okay. If you're going to use your hand, you need to actually follow the directions. Are you following what it says up there? Okay, it does say 333. Somebody should have called me out, and this should be 332. People playing along at home like Lucy. All you've missed so far is me passing out papers. We are here checking out Newton's Revenge. We should be getting to this. So you want to try to balance those dots equal above and below. Mr. Jones, would you give them a dry erase marker to every group and make sure they each have a whiteboard? All right, I want your team's equation written on a whiteboard once you all agree. So Mr. Jones is going to come around, make sure you all have what you need. We're going to write it on the whiteboard. You got to chat about the slope. Watch out for those scales. Chat about the y-intercept.
Oh yeah.
That was great. Great.
That's a shade.
You guys think you can wrap this up in 2 minutes? Decide on your equation in the next 2 minutes? That's why I learn kids' names, passing out homework. Literally, like this year, I just learned them quicker than ever, and I swear it's because passing out homework.
Yeah. I used to do it with con better, but now that we're doing paper homework, con was fun because it was like kind of like almost a game.
It's not what you think the y-intercept is. It's what does your line show?
Yeah. Our line on here it shows 3.4. Oh, sorry. Let me just.
The one that I made has a 16.5.
Yeah, just do that. We'll just use yours because yours smarter. You two are not yours smarter. As long as we have to read on the scale and the lines.
I don't think I finished grading everything you would. I don't think I noticed this backside, so I think I need a little bit more time with this. I'll get it back to you later, though.
It looks like 4.35.
For me, this is
What? I made 3.25.
Jack Carter. So you're going to 1665.
I think I got your guys' cards.
Alright, which one makes this?
Yeah, the scale is like kind of bad.
All right, can we get equations written down on a whiteboard, please, so we can compare what we've got? Got to decide. There is no risk on if you get this wrong, but we got to decide so we know, did we have it right or wrong? And if you are sneakily doing your homework and not participating with your group, how dare you? What a bad group member.
I'm not lollygag. I participated in my groups and now I'm working on my homework.
As long as your group has your equation decided.
We do.
So I like that Desmos shows our axes values, even if we can't see the axes. Like the more we play with this, hopefully you guys are noticing we can still see those numbers, even though we can't see the axes. But it makes a whole lot more sense if we can see the axes. So Nolan, are you happy with where my line is right now?
No.
How should I adjust it?
You should make it so it's like going up and through the dots.
So up and through the dots. All right, like that?
Pretty much.
Pretty much?
I
What, Madeline, could I do to make this better? Or to check if it's good? Zoom back in. See how many dots ended up on each side. 1, 2, 3, 4, 5, 6. 1, 2, 3. These kind of count as like going through. So I don't know that I think we're really balanced right now. Chase, what do you think?
You could like move it slightly like that. It's like
So move the bottom up or move
Yeah.
this up, down? Like,
bottom up slightly.
Very slight.
so I gotta zoom out until the point that it lets me move. So very slightly, you would say. Now I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 maybe, if I call that 6. But so 5 and 6, is that pretty balanced?
Yeah.
Yeah. I want to see what you guys wrote as your equations. 2/3 x plus 17. Harrison's team, Lila's team. You got something written down on a whiteboard? Great. So we just chose not to do what we're doing. 25x plus 10. What'd you guys have? 3/4 x plus 16.5. Is that 2/5 x?
3/5.
What? 1/5. Okay, that's very important discernment there.
Well, it's kind of exactly.
Well, okay, so let's talk about that. I'm glad you pushed on that. What was your guys' y-intercept? 17. What's your guys' y-intercept?
30.
30. Do we? What's the right answer here? They have 10. Arnia's team has 10. 16.15. Okay, what, Lydia? What?
I mean, as long as there is no when it's a line with best fit, there's kind of some wiggle room. It's not one specific right answer. Like when
Until. You can go ahead and finish your sentence. Sorry, I didn't mean to interrupt you.
like there's not just one specific correct answer. Like when you're like graphing a line that has a bunch of points going in a straight line.
Until we use a computer to do this for us. So, we're not learning this today. But the whole point of practicing this again, just like we did with the plant data last week, is can we set up a line of best fit? Can we determine slope? Can we figure out the y-intercept? Y-intercept's easy, right? And yeah, it's the bad word. But why? I keep forgetting it won't do the 2 finger zoom. Y-intercept is wherever I hit, which my y-intercept looks like the origin. How did you guys find your slope? Did you use your purple points, or what'd you do? By the way, your card like came up, and that's why I kept calling you. But Jack, I am using cards, so I'm not just not calling you. Jack, how would I find my slope? Doesn't have to be exactly what you guys found, but how would I find mine?
Rise over line.
How do we do that?
See how many points or units it goes up
Am I using my purple points, or what am I using?
the line.
We're using the line now, and what sort of points do we want to look for? Started with an L. Anybody? Lattice points are nicer, and they are at like the crosshairs. So let's say that I use, I don't know. What did you lock? Lock. This one looks really good as a lattice point, right? This one looks pretty good. So this is just to make your life easier. And then we do what to model the rise and run and make our life a little easier to look at this? What do we draw? The slope triangle. Whether you come this way or this way, I like to do the rise first and then the run. Check your scale, right? These are going by 20s. Each of these is 5. Got our Y scale over here, depending on your zoom. So this is like 160, I don't know. No, like 170 really. If we come over here, that's at like 170. Let's see how close your slope was to this. To 100. What's our delta Y? Up here. It doesn't have to match yours. What's my delta Y? 70, right? From 100 to 170, my delta Y is 70. My delta X, 130 up to 220. Let's see how close this gets to what you guys got. How far is it from 130 to 220? 90. So wait a minute, this comes out kind of nice. What's my slope? Guys, what's my slope? If my delta Y, if they're both multiples of 10, what's my slope? 7/9. Right? My slope here is going to be 70 over 90, or 7/9, which is about 0.7 repeating forever. Because over 9 repeats forever, right? So if your slope was near 0.7, which I know we said fractions are better, but if you calculate that your slope is near 0.7, you're pretty good. Until we learn how to use computers to do line of best fit, we're going to all get different equations, right? There's not one right equation. So your y-intercept here, those are cards I've called on. Rowan, talk to me about your guys' y-intercept. So what was your y-intercept? 17. So that, what does that tell us? If you got a y-intercept of 17 here, so like if we think about the slope, right? The slope is relating to x and the y. No, don't open paint. This one, the smartboard doesn't work. Guys, talk with your team for a second. What is the y-intercept telling you here? And does it make sense? Chat with each other for a minute. So I'm going to try to get more like you guys, where my y-intercept isn't the origin. Here's that table again, if you're trying to remember what was what. Our x was height, our reach was y. Our x was height, our reach was y. Kira, at your y-intercept, what's 0? At the y-intercept, what is 0? The x, right? The x value at the y-intercept, the x is 0. So here, the x is our height, right? So what is the y-intercept telling us? Bless you. You got any thoughts, Caroline, what the y-intercept is telling us? If x is 0, we just said x was our height. What's our y-intercept telling us here? I'll pass. Aaron, thoughts? It's because this is weird. And like, it's not like what we've done before. Lila, thoughts? Guys, think about this with me for a moment. Oh, come on. Now you broke. Fantastic. Ah, there it is. So guys, this y-intercept is telling us, and if you're on your computer, please look up here. if this is 0, let's just say, I don't know, 17, like some of you guys said, our x, we said, was our what? Height. And our y was our, like, how high you reach, right? So this is telling us if you have a height of 0, your reach is 17. Is that possible? You don't exist. You have a height of 0. You don't exist. But your reach is 17. This doesn't make any sense. So guys, this, like, as we get into the next couple chapters, all we've been doing is linear equations. But this linear equation now tells us you have no height. You do not exist, but your reach is 17. It doesn't make any sense. Maybe. I mean, so Lydia's saying the y-intercept should be the origin. Or does a straight line match this data appropriately? Like, there are other questions we need to ask and, like, threads we need to pull on. We'll look more at that as we get into the next chapters. I have one last thing to teach you this chapter, which is on that resource page that I made for you guys. So get that resource page out. Get that resource page out. Forgot we want to review this real quick because I figured you would have 732 out. This is in your math notes also. And I wanted to do like an I told you so sort of thing. I think we can halfway close our Chromebooks, at least for now. Because the Chromebook has nothing to do with getting to that resource page. So on 732, where it says examples in class, so we're going to really quickly just go over this and go past it. If we were being asked about strength of association, like on your homework, where it asks you strength of association. Can I get eyes up here for a second? Let's look if we went to Schoology and looked at those notes. If we went to our math notes in Schoology, there is strong, moderate, and weak. If we're claiming there's an association. If you go past weak, you're like, oh, what's worse than weak? There's no association. If you're worse than a weak association, there is none. So how could you describe strong, moderate, weak based on what? How would you say this, Vivian?
Like how many dots it goes through?
How many dots it goes through? Sure, I'll take that as one way to talk about it. Lydia?
How close the points are to the line.
How close the points are to the line. A couple hands went down after you said that. Ooh, how close the points are to each other. So really what this comes down to is like how tight your data is following that pattern. Right, and this, as you get up into higher math, you don't need to know this yet, but these are what we call residuals, how far away it is from the line of best fit. So as you keep doing more with line of best fit, and this is going to be one of those things where you're like, huh? This is an abbreviation for line of best fit.
Huh?
It stands for least squares residual line. That's when your calculator is doing all the work for you. So LSR, you're going to get there, but before we totally move on from line of best fit, you're going to end up getting technology to do it for you so that you all end up with matching lines. Any questions remaining about that? Use the notes. Moderate, weak, strong. Obviously strong, super tight to the line. Weak, almost. I mean, I could argue this almost looks like it has no association, but they're calling it weak. Yeah, like I will say we're empty over here, right? Like we don't have any points down here. We don't have any points up here. So it does seem like there's an upward trend, but it's pretty weak. All right, grab that resource page. I want you guys to start looking at that corn data and determine what do you think the farmer would be comparing. Like we have column data and we have row data, right? Our column data is the heights. Our row data is the soil types. Chat with each other about what you think the farmer would care to compare. I'm a poet. I didn't know it.
How high the corn would you go?
What do you think the farmer would be wanting to compare?
Right?
Yeah, I was
What are
thinking of total.
But what are their notes?
Yeah, wait, why does it
Ooh, I will tell you, all of the seeds are the same. All of the seeds are the same because I'm listening to your conversations. All the seeds are the same.
Oh, we want to use the
I was gonna say
Now, some of you have potentially never grown anything in your life. What? Some of you. I didn't say all of you.
no, I'm just surprised.
So, Harrison, do you have a thought of what the farmer might be trying to analyze here? So we're essentially making our soil type the independent variable, right? Saying, I'm going to plant some corn over here in sandy soil. I'm going to plant some corn over here in clay soil. And then the height we would call if that's our independent, this is our dependent, right? Our height is our dependent. So height depends on soil type, right? So he's probably comparing which soil, and I heard a couple groups say it, is better, right? Do you want shorter corn or do you want taller corn? Taller corn. So this table has all of our totals. It's got our row totals and it's got our column totals. By the way, if you want to make a note of what a frequency table is, it just puts your data into a table. It's on the back where we really need to write down what the other vocab word is. You don't need to go there yet. So here's what I want you guys to do. If we're going to compare sandy to clay soil, which totals do you think we're using? The row totals or the column totals? If we're comparing like this soil versus that soil. Carter?
column totals.
So we're going to make this 100% and this 100% and this 100% and this 100%. Like if you're saying we're using column totals, these are now our 100%. So then my groups that I've made are short, medium, tall, and tall. Now you're comparing those groups.
Oh, no, you want to use
So you want to retract that.
Yeah.
And you're saying we're using these totals?
Yeah.
You are correct, because we would like to compare those two groups. So we want sandy soil, this to be our 100%, clay soil, this to be our 100%. So what we're going to do with this table is fill in our percentages. And Carter just said we don't really need this total. We care about these totals. So what you could go ahead and fill in is this should total up to 100% when you add up all of these. This should total up to 100% when we add up all of the clay soil percentages. And it looks like we're just not going to use the bottom part of that table now. So let's convert this into percentages. You're going to need a couple minutes, and you're going to need some calculators. And you guys can share answers with each other. That's what makes group work so nice.
I'm gonna do the percentages with clay.
Oh, you can claim what type of soil you want to do and then share your
And
answers.
Carter, you have a calculator. So.
I use sandy soil.
Yay, teamwork. Okay.
Then we're gonna make histograms to match that data. So if you want to know then what, then we're gonna make histograms to match that data.
Lydia has one.
Then we're gonna make histograms to match that. Round them. Yeah, round them. Round your percentages either to just the tenths place or just round it to a total percent. Either round it to tenths place or round to total percentages. And if you total up to like 99% or total up to 101, it's okay. Because if you round, it's going to mess up your total.
You shouldn't say that around me. We should round to the hundreds.
No, I don't have soil. Computer, I just
Yeah, make sure you're not just letting only one person do the calculations. You want to double check. If you got a group of people, use the fact that you got multiple brains.
I'm so good.
It totaled up to 100. You're so good. So guys, once you fill in all your percentages, we can go make that histogram that I already set up for you. I'm trying to make your life easier. You know how to calculate percentages? Is there a reason your page is blank then? Yeah. So we're saying like 150 out of 1675 is what percent? Right, so that's what we're doing right now. Oh, yeah, we need to put screws in. I just moved this in here yesterday. Yeah, so that is why we had these. You can write on these. I meant to bring a scraper today. This is super old, so I'm not worried about germs. Like I wiped this down, but you can just put this right here. You can just put it like that. So we're still trying to utilize these new tables. People have been saying they like them better because it's easier to group them. Man, if we get to Jenga today, I'm gonna have to like resort my cards back into whatever teams you guys are in.
I think we yeah, we did.
Jeff, so you take the small number and then you press the division symbol and then you take the big number.
And then you move the decimal. So do we know how to find these percentages? Well, then we're not doing okay, right? So should you ask a question to your teammates or team? What do you want to pick? Ask them or ask me? Then speak up. Say like, hey, what are we doing? How are we doing this? Will's keeping that accuracy. Yep, and then we're gonna make a histogram for them. So once you get figured out all your percentages, we're gonna take that data down into the histogram.
99,
Hey Carter, did you make your histograms yet? Notice how I keep repeating myself with and then, and you also don't have your placeholder
Yes.
percentages.
They're doing the place.
Okay, great, but then you need to be like with that.
So placeholder 1 is not 1 0. Okay. What is it? 42
Remember, your histogram technically shouldn't have space between the bars. Bars should be like right up against each other.
So it's 27.
Alright, so their explanation. How is this helping us? What do you do? It's easy.
30.
So, you just want to divide by what?
So the second row, 3 to 4 is 18.
5 to 16, 75.
And then after that it's 24.
Now you can either in your head make the decimal or hit times 100.
After that,
If you have a calculator for you, just hit times 100. There we go.
you guys have
So
six.
round that off. I think that was round. I think it was like 9.5. I did.
9%.
Oh, I just got nothing. Alright, yeah.
Okay, you can't leave anyone like behind, right? You gotta make sure your whole group is moving together.
Then 34. Then 45.
Stop blurting out answers.
Stop being
And then make a decision as your group of which soil you would choose. Which soil would you choose?
I choose Sandy.
Never mind. Actually,
Wasn't Sandy the chipmunk from SpongeBob?
Yep.
What was her last name? Why am I struggling so hard?
Sandy Cheeks.
Cheeks, yeah.
We just got
I mean, you also just made me like have a memory of just sitting in my parents' living room watching SpongeBob. right, so I think I can just go ahead and fill in my table because it looks like we all pretty much agree. So if you have dramatically different answers, maybe check with your team because you shouldn't. And all the tables that I looked at had similar answers to what we should. We gotta make sure that we all got histograms for this.
Either no or the same result.
Do we remember how to make our histograms? Okay, Vivian?
Yeah. Wait, what's the percent of stops again?
assuming that weather conditions.
So that's what you found right here, right? So like that. So this should be 9. Orange, white, sandy soil. Yeah. So 0 to 3 should be 9%.
So are we assuming that for the sake of math, all the constants are the same?
Yes. Yeah. Yeah. Everything else has been controlled. So technically, with a histogram, the bars should be touching each other because there's no gap between the 3-foot section and the 3 to 4-foot section. Like there's no missing gap. You know what I mean? Like this is everything we have from 0 feet up to 8 feet, and that's why the histogram runs into each other. Is like either the corn stalk fit into this part or that part, and there was no gap between. It was either that one or that one. It is very curious that you have like a perfectly spherical piece of ice in here. I mean, not perfectly, but like very spherical. That's interesting. Oh, we don't remember how to make a histogram? So this is not a histogram. Go ahead and erase this. So a histogram is like our bar graph that has like the bins. So our bins have been set up close. So your 0 to 3 foot bin for sandy soil. What was your percentage? Yeah, so that's what we want to make our histogram bar show. Ah,
If it's 6
love it.
supposed to be in here, why is 6 in there? Like if it was 6.1
All right, young farmers, time to make a decision. I think this is the stack I already called on. I don't know. I'm shuffling all the cards back up. I don't know what's going on. If you haven't been called on today, I'm sorry. I got mixed up. All right, young farmer Will, do you have enough data calculated yet to tell me sandy or clay? What are you going to pick to plant your corn?
I'm gonna pick. Let's see. I'm gonna choose sandy soil
Why is that?
because we have more. We have a higher percentage in the 7 to 8 feet zone.
Okay, Will says sandy soil. Liam, what are you thinking? Same reason as Will, or you got your own reason? Same reason as Will. Caroline, what are you thinking?
I think sandy soil.
What's your reason?
I think even though it takes a little bit longer to grow than clay soil, you'll get more percent of stalks.
Yeah, right. If we just like literally compare. Now I'm confused about what you said about maybe even if it takes longer. I don't know if we know how long it took here. I think they just like went out to the field and like checked everything at like the same time, right? So I don't know if there's actually any time difference. There might be, but we don't know, right? So be careful assuming anything. Guys, look at the graphs. Which one has more short stalks? By the way, the corn, if you don't know this, is on a stalk. It's a corn stalk. The clay soil has a ton of short stalks. Guys, anyone know the phrase about how high corn should be in July? Caroline?
An elephant's eye.
Ooh, wait, so give me the whole phrase.
The corn should be as high as an elephant's eye.
So by the end, right, but so how I grew up out in Coshocton, right, is knee high by 4th of July. And that's when it's young. That corn should be knee high by 4th of July. And then, like, I forget the other phrase, but then as tall as an elephant's eye, like when it's full grown, because then you get more ears of corn. We're not getting much corn off of these. And that's like 27% of my guys, if you're paying attention to anything right now, like farmers are struggling. They need as much income as they can. We're getting a lot more ears of corn over here than we are with these. So yeah, forget about those short stalks. Let's get a bunch of tall stalks. Questions about the corn? Flip to the back. We're going to analyze, will any of these fitness bars help us lower our blood sugar? So the data you've been given. Some people volunteered to come in and eat these fitness bars. They literally, like, my wife does this. There's a survey place here in Dublin. It's connected with Wendy's too. When you're an adult, you can sign up to take surveys, and you can get paid to just go in and eat something and give your opinions about it. Now here, they ate the fitness bar, and then they checked their blood sugar. Because what they wanted to know is, will this fitness bar, like, can we claim that it helps lower blood sugar or not? And if so, like, which of these bars is the best, or which of them is the worst? So here, Jack, what do you think we're comparing with this table on the back? Are we comparing high blood sugar to low blood sugar, or comparing the types of bars?
High blood sugar to low blood sugar.
I don't know if you were listening as I set up the premise. Well, I'm going to keep using Lydia.
No, different kinds of bars.
Yeah, we're comparing, does this bar lower blood sugar, does this bar lower blood sugar, or does this bar? Do any of them? We want to compare the bars. So where should we put our 100%? Think back to the front, we compared the soil, and we put our 100% off to the end, aren't you? So on the front, we put our totals out here, because we had sandy soil, clay soil, and that's what we were comparing. But now we want to compare the bars to each other. Lila? We actually need to put our totals here. We need a column total to compare the bars. Because you're comparing mighty versus force, force versus strength. Like, we need to total up the bars to compare them to each other. I know this is new. This is the last thing that I'm supposed to teach you this chapter. So you first want to find your totals. Then we're going to make a relative frequency table that is conditional. Here's why. So give me a second. Stop writing for a moment. Because I'm going to let you write whatever definition you want. Conditional is what we just discussed. What's the condition we're looking at? We are trying to compare the bars to each other. So our condition is it a force bar? Is it a mighty bar? Is it a strength bar? Relative frequency turns it into percentages, because do we have equal amounts of data up here? No. How many people ate the mighty bar? Only 150. How many people ate the force bar? 500. So our data right now, can I compare 120 to 409? No, I can't compare those numbers to each other. I need to make a relative frequency to then be able to compare. Because this is 400 compared to 120, but 120 out of 150. 400 out of 500. What's our total over here? Might as well say it. 350? Can we double check that? I don't know what is it.
Yeah, it's
350? 350? All right, so go ahead and make your relative frequency table using that blank table. Turn it into a relative frequency. We're going to figure out the relative frequency. Like, guys, you could use the decimals, because when you do the division, you get the decimal. So you could honestly just use the decimal value, or you can convert to percent. You just have to do the same thing with all of them. Whatever you do, do it with all of them. But if you're using percentages, you have to have percent signs. Yep, because otherwise it just looks like numbers like it did up here, right? You gotta have percent sign if you're doing percent. And then we're gonna make histograms. So I'll give you a couple minutes. sense. You got it, but it's sense.
Yeah, I like the mini bar because it don't have the
Sorry, start that question again.
yeah, it looks like Mighty Bar.
I don't know. Like, I just don't understand the question, so I don't know how to
Mighty
answer.
Bar is just
I don't think so because they're literally different food. So like I don't think this is like they said just make a mistake. Like I just think the data that we have is just very close. Like, I get why you're asking that because they seem very very close to each other. That maybe they should have been the same. They're not supposed to be the same. They just come out almost the same. Sorry, I know this is annoying. Maybe I'll bring my drill back when I go home. We didn't want to secure it until we decided if it was actually going to stay here. But maybe we should just go ahead and do it.
350. I love these benches. They're so useful.
Did you make your histograms?
Oh,
Since you're discussing my board. Resource, what are you doing? Finish the resource page, then you can do your homework. What? You know my policy.
It's just funny to hear a teacher saying, then you can do it. It makes sense, but it's funny taken out of context.
I don't know if it's ironic.
It's not ironic, but taken out of context.
Like rain on your wedding day, not ironic. There's a whole song, I forget who it was. You're probably too young to even. Yeah, if the song's on, I can sing like most of it. It is funny that everything she says is not ironic. Is that Alanis Morissette? Now I have to know.
But it's all like tiny differences.
if you're going for low blood sugar, I guess the Mighty Bars.
Yeah, ha! I got it. It's Alanis Morissette. Yeah, her song "Ironic" is what we were just talking about. Because Carter said it's ironic, and I said I don't think it is. People often use the word ironic incorrectly. Like, oh, that's ironic. Like you just are just using the word that you know. All right, so I think most of us agreed we were at like 20% and 80%. That 8 does not look very good. Looks like some of what you guys turned into me. I need some help though on the other ones because they're too detailed to memorize. So Rowan, help me out with the force bar percents. So there's 1% lost somewhere to rounding, right? That's okay. Like we get it when we're rounding, we're probably going to drop a little bit here and there. My brother-in-law used to work for Maine Medical Center, which is like a big hospital up in Maine, with the E, like the state Maine. Their margin of error that was allowed through the year based off like how many Band-Aids did they purchase, how much gauze did they purchase. Their books at the end of the year, like how we're off by 1% now, were allowed to be off by $1 million before anybody cared
What?
because of rounding. So you think about what they pay for Band-Aids, but then like they charge you for 10 of them if they use 10 on you. Their price for 10 Band-Aids is probably going to get rounded because they can't keep all the decimal places. So through all of the rounding, through a whole year, they literally could be off by $1 million and didn't care because how much money they were like dealing with. So when we're off by 1%, that's okay. What about strength bar? Nolan, help me out.
I had 19 and 81.
Ooh, 19 and 81%. So then Harrison asked a really good question. He called me over and he said, is this just because of like a margin of error, which is like statistical, like you expect things won't line up perfectly just because humans? But were they eating the same thing? No. Question mark? Why might we think that they were eating the same thing?
It's all very similar.
The data is almost perfectly matched. So when you make your histograms, they all probably look pretty much the same. So I don't know what company this set up. This is all fake, right? Most of CPM data is real, but this is fake. Can they claim their bars lower blood sugar?
I mean, they could look say, oh, it lowers 0.00001%.
If we look at the data we have, what do their bars actually do?
Raising.
For 4 out of 5 people, right? If we reduce this fraction, for 4 out of 5 people, it's elevating their blood sugar. They should probably just say nothing about blood sugar, right? Like, this is where certain companies will claim, like, this thing does this for you. And they don't talk about what else it does. So they might be like, the Force Bar is only 100 calories. It's a great 100-calorie snack. And they're never going to talk about blood sugar because they don't want to tell you what you don't want to hear. Take a break. My advice is leave my classroom. You should be back within like 4 minutes because I think we're probably going to try to start Jenga to get some of that closure done today. Take a break. My advice is get out of here. Go stretch your legs, get a drink, take a break. What?
I just said let's let out a very exasperated sigh.
Okay.